Now that we know how to convert between units, we can start to apply that to some calculations within chemistry. On page 98, write your title, Notes About Mass. We learned way back in the start of the year that mass is the amount of stuff of something. Okay, so now we're going to talk about some different forms of mass. The first one is the atomic mass. Atomic implies that we're talking about atoms and mass being mass, so we're talking here about the mass of an atom. This is measured in what we call AMUs, or atomic mass units. It's a very, very small number. We cannot measure the mass of one atom with our balances in our classroom. So how we find out what the mass of one atom of any element would be is we can look at the periodic table. The example we're doing here is sodium. We see the top number is the atomic number, we have the symbol, the name. That bottom number is the mass number. So we're going to write down 22.99 and our units would be AMU. Make sure to note in your notes that this is found on the periodic table. The next type of mass we're going to learn about is molecular mass. We learned last unit that molecules are sets of atoms bonded together. They can be bonded ionically or covalently. When we're talking about molecular mass, this is the mass of a molecule. This is measured in AMUs again, so it's really, really small because one molecule is a pretty small amount. To find it, we add the atomic mass of each of the elements involved in the molecule together so that we can find the total mass of all of them. Kind of like if you had 6 people on an elevator and you wanted to know the total weight in there, you'd add them all together. So our example here is going to be NaCl. We have 1 sodium and 1 chlorine, so we write that down. We're going to multiply the number of atoms of each element by their atomic masses. We saw that sodium was 22.99. Now we're going to find chlorine here, the bottom number, 35.45. Since they both have 1s, I don't really need to do the multiplication, and I'm just going to go ahead and add these together. So I'm adding them together, and I get to my final answer, which would be 58.44 AMUs. Last type of mass we have to talk about is what we call molar mass. Now this is the mass of 1 mole of any sort of substance, be that atoms or 1 mole of some sort of compound. This is measured in grams per mole. So when we talk about the mole next week, we're going to learn that the mole helps us to relate something that's really tiny into a mass amount that we can measure. The nice thing about molar mass is it's the same as the atomic mass for single atoms or the molecular mass for molecules or compounds, but we just change the units. So if we've already found the atomic mass of, say, Na, sodium, we just change the units on that from AMUs to grams per mole, and we've got the molar mass. The example here that we're going to do is the same as the last example. We're going to do NaCl. Up there we found that it was 58.44 AMUs for the molecular mass. For our molar mass, then, we would have the same number, 58.44, and our units would be grams per mole. That's all the notes we're going to take, but we're going to have a couple questions quick to check for understanding. So your critical thinking questions here, write these down. You're also going to answer them in the question box below. You can use your notes for these. The first one is, how or where is mass found? So where do we find things like the atomic mass? The answer would be on the periodic table. We find all of those numbers on the bottom number in the periodic table. The second question is, what is the difference between molecular and atomic? Oh, nope, not atomic. Cross that out. Molecular and molar mass. The difference there would be the units. So molecular mass is measured in AMU, and molar mass is in grams per mole. Now we're going to do some practice problems. Tape the sheet into the next page in your notebook. The first one we're going to look at here is carbon. We got to find its formula, so that's the symbol in the box that says carbon. That would be the C. The bottom number there is going to be our mass number, so I write that down as my atomic mass, and the atomic mass has the units AMU. So I have 12.01 AMU. The molar mass then is the same number, but the units are grams per mole, so 12.01 grams per mole. For F2, F is fluorine. The 2 means that I have 2 fluorine atoms bonded together, so now I need to multiply the mass on the periodic table by those 2 atoms, because the mass on the periodic table is only for one of the atoms. So I have 2 times 19.00, which is what I found on the periodic table. That gives me 38.00 AMUs. The molar mass, again, is the same number, but a different unit. So I have 38.00 grams per mole. Getting into a couple trickier ones now with atoms of different elements, I have Ca, that would be calcium. I'm going to name it first. Calcium. And then the OH, looking on my purple polyatomic sheet, is hydroxide. So I have calcium hydroxide here. I go to count my atoms and I see that Ca does not have a subscript, so there's one of them. The 2 on the outside of the parentheses there applies to both the oxygen and the hydrogen within the parentheses. So I have 2 oxygens and 2 hydrogens. Now I look up the different masses on the periodic table for each of the elements. Hydrogen is 1.01, so that's going to get multiplied by 2. Oxygen is 16.00, that's going to be multiplied by 2. And calcium is 40.08, that's going to just be multiplied by 1 because I only have 1 calcium. So when I do my multiplication there, and then I'm going to add up those numbers to get the total, that number, the number that I add here is going to be our molecular mass with the unit AMU. That's be 74.10 AMUs. And then again, our molar mass is the same number, but now the units are grams per mole. The last one here is ammonium sulfate. Both parts of this, the cation and the anion, are polyatomic, so you're going to look on the purple polyatomic sheet. Ammonium is NH4, and it has a +1 charge. Sulfate is SO4, and it has a -2 charge. So when I crisscross my charges, I get NH4 in parentheses with a 2, SO4. When I go to count my atoms, that 2 on the outside of the parentheses applies to both the nitrogen and the hydrogen. So I have 2 nitrogens, and then because hydrogen already had a 4 on it, I have to do 4 times the 2 on the outside, so that gives me 8. Sulfur, I have just 1, and oxygen, I have 4 of them. I'm going to now multiply by the masses on the periodic table. So I knew oxygen was 16, I knew hydrogen was 1.01, nitrogen I see is 14.01, and sulfur is going to be 32.07. So I'm going to do the multiplication there, 2 times 14.01, 8 times 1.01, 1 times 32.07, and 4 times 16. Once I get those answers, I'm going to add them all together. So 2 plus 8 plus 7 is 17, carry the 1, 8 plus 8, or 8 plus 2 is 10, plus 8 is 18, plus the 2 is 22. So 2, carry the 2, 2, 4, 6, 7, and I get a total of 13, which would be leave me with 132.17 AMUs. Again, the molar mass is the same number, but in grams per mole. So I get 132.17 grams per mole. In this last free response question, please write any questions you have about this video so that we can address them when we're in class on Monday.